In the previous video, we have understood some basic concepts related to the modal analysis. We have understood about what is modal analysis, why are we performing modal analysis, what is natural frequency, what is a mode shape, okay, and we've also understood how to add the modal analysis and modal analysis system to the project schematic window. Now we will take our first problem. In this problem, you can see the model on the screen. We need to calculate the natural frequency of the model. The model is made up of an aluminium alloy and it is fixed at the hole over here. Okay, there's a fixed support that is acting over there. Now, as we understood in the previous video, that natural frequency is a frequency which occurs in the body when it starts vibrating on its own in the absence of any external loading. So in this condition, we are not going to add any external loads on the model. Okay. So now let us perform the analysis. We will go into the Ansys Workbench analysis system. We will add one modal analysis system over here. The material that we have to use is aluminium alloy. So I need to add the aluminium alloy and then return to the project. Now we will add the model. Either you can create the geometry or else you can import it. So in this case, I am going to import the model as I have already created the model in the CAD software. Once you come over here into the design modeler, once you come to the design modeler, because the model is symmetric, you can create half of the model. Okay. So I will come to Tools, Symmetry, and I will cut the model along the XY plane. I will cut it along the ZX plane, and then generate. Okay. So this is the half model that we have. Once this is done, if you want, you can also merge these spaces. Have been merged. So the same thing has to be done over here also. I need to merge these pieces. Okay. So now that the model is ready for analysis, we will now take this into the mechanical window. Okay. Now once we come to the mechanical window, we will first see whether the model has been generated correctly or not. Can see that the model has been generated correctly. I will change my material to aluminium alloy, and now we will generate the meshing. So first I will use the default mesh settings. Okay. After that, if I want, I can use the proximity and curvature to generate finer meshing. Now you can see the mesh has become much more finer. Okay. After this, now we will apply the boundary condition. So in modal analysis, now whenever you come to modal analysis, there is one more thing that you need to do is, you need to change the analysis settings. Click on the analysis settings and come to the details tab. In details window, you will see maximum modes to find. By default, this value is always at 6. When you say maximum modes to find is 6, it will calculate the frequency, the first 6 frequencies for the design. Okay. So now, if I wish to have 10 frequencies, the first 10 frequencies, you can add that, or you can have only the first 3 frequencies. It is up to you. So let us say I am interested into the first 6 frequencies. Below that you have one option which is called as limit search to range, which is now set to 0. Now let us assume that we have a range for calculating the frequency. That means my maximum range is only, I'm only interested into the frequencies up to 5000 Hertz. Beyond 5000 Hertz, I am not interested into that frequency. So for that, I can say limit search to range is yes, and the maximum range I can mention over here is only 5000 Hertz. Similarly, let us assume that this model is connected to another body which is already excited at a frequency of 200 Hertz. So now I know the starting frequency on this model will be 200 Hertz. So I can also start with a minimum range of 200 Hertz. So in case the analysis that you are performing on has any limits like this, you can set the limit search to range as yes, and then you can enter the minimum range and the maximum range. Or else you can say no and you can perform. When you say no, it will start calculating from 0 Hertz and go up till whatever value till it achieves first 6 vibrations. Okay. Then if your model is damped, you can say that yes, there is a damping option, and then you will get the damping controls where you can enter the damping coefficient. Okay, but that is only if your model is damped. Okay, otherwise you can say no, right? And then we will have to add the support. So in our condition, we have the phase over here which is going to be fixed support, and there is no external load. Anyways, you cannot add any loads in the modal analysis. Okay, so whenever you are performing modal analysis, no loads can be applied except the thermal condition. And now we will select the solution node, and we don't need anything over here. We will not select anything. We will just say solve. Once you say solve, you have to observe the tabular data over here. Okay, so you can see the tabular data. It has calculated the first 6 frequencies as we have requested. So the first frequency we are getting it at 920.57 Hertz, and then it will go on increasing. Now we have understood what are the frequencies. In this we will assume that the first frequency that we achieve is the natural frequency of the system. And then we now have to understand the mode shape. Now we have to calculate, or we have to determine the mode shape at every frequency. So for getting the mode shapes, select all, right click on the tabular data and say select all, or else you can also click on the graph, right click on the graph and say select all. Both the methods are okay. And then we will again say create mode shape results. Once you select all, again right click and say create mode shape results. So you will see that the deformations are generated for each and every frequency. And then again we will say right click and we will say evaluate all the results. So now you can see that at every frequency, what is the mode shape. So at second frequency, the mode shape that you are getting is, and the deformation is 225.89. So you can see how it is vibrating. Okay, and you will also observe that the first mode shape is in the X direction, second is in the Y, third is in the Z direction, fourth will be in the rotational X. You can see it will rotate about X, right? Then rotational Y. See this, look at the Y direction and look at this. And then finally sixth will be rotational Z. So it is in the order first 6 degrees of freedom. Translation X, translation Y, translation Z, rotational X, rotational Y and rotational Z. Okay. So this is how you will perform. Now if you feel that the vibrations are more, you can add a support over here Okay, you can strengthen the model in this direction in which it is vibrating, and you can reduce the frequencies, or you can reduce the vibrations over there. Okay. So after the modal analysis is done, you also need to take some corrective action so that the vibration is reduced, or in some cases you might have to increase the vibration. Okay. So this is how we will perform a modal analysis on a model.